Hello, everyone. Welcome to 832 Day 2. Today, we're going to be talking about the same thing that we did yesterday. Our goal here is to find roots of higher order polynomials, so polynomials that have a degree greater than 2. And we want to use a mixture of algebraic and graphical techniques to help us factor the polynomial and find the roots. All right. So, in other words, we're trying to take a higher order polynomial, again, something with a degree greater than 2, and get it into its factored form. Right. So, this is our goal, right, to get something that looks like this. We can tell from this polynomial, it's a third degree polynomial, so we should have three linear factors when it's all said and done. So we're gonna find those three linear factors and list the roots here. All right, so just like in yesterday's video, we did a really easy example yesterday where we could see all three of the roots on the graph and they were nice, easy integer roots. So really, if we wanted to, we could have just picked those roots right off the graph and written our factored form without having to do anything else. And if you can do that, you should. All right, but we're going to take a look at an example today where we might not get nice, easy integer roots. Sometimes they're decimal, sometimes they're complex, and you can't just pick them off of the graph. So we do need algebraic techniques sometimes to find some of those roots. But we're going to start the same way that we did yesterday. We're going to start here, step one. We're going to check the graph. So we're going to take our polynomial here. We're going to enter it into Desmos, and we're going to examine the graph and see if we have any x-intercepts. Okay. So this is our first polynomial here. So we're going to graph this one. You see it pop up on the graph here. We have one root here at -5. And then we have these other two, and you'll see these ones are decimals, and sometimes these seem like nice decimals, but sometimes they're never-ending, non-repeating decimals like irrational numbers. So it's really hard to get an exact location of that root. Okay, and when that happens, we need to find those algebraically so that we can get an exact value. All right, so this root is real nice. So this one is at -5, and that is the root that we found. So we're going to say what roots did we find? We found a root of -5. The other two are decimals, so we need to verify those algebraically. All right, so if we have a root of -5, that means that we have a factor of x plus 5. So we have one of our factors. We need to find the other two. All right. So going down here, we're going to find the other two using Polydoku. First, we're going to take our original polynomial. We're going to divide it by the factor that we have. So I'm going to take this x plus 5. I'm going to put it here along the side. And then I'm going to take my original polynomial, write it down here along the bottom, and we're going to do a Polydoku. So we got 20x cubed plus 106x squared. And my short-term memory sucks here, plus 28x minus 10. There we go. And remember, essentially what we're doing is we're taking our original polynomial, 20x cubed plus 106x squared plus 28x minus 10, and we are dividing it by the one factor that we know we have, and that is x plus 5. And if x plus 5 is indeed a factor of this polynomial, then it should divide into it evenly. And when we do divide it, we should get something. We should get what's left over here. This is the result of the division, is this polynomial across the top. And this is where our other two factors are contained. All right. So we're going to go ahead and do this Polydoku. We're going to take that 20x cubed. It goes in that first box here in the upper left-hand corner. And we start working our Polydoku. So we got x times something gives me 20x cubed. Well, that's got to be 20x squared. All right, and then we multiply it down. So 20x squared times 5, that's 100x squared. Use your diagonals. Remember, the diagonals contain like terms, so we're going to have 100x squared plus something here, right? When I combine these two boxes, we should get 106x squared. So we need 6 more x squareds in this box here, right? Then we can take x times something gives me 6x squared. Well, that's got to be 6x. And then we can multiply down. So 6x times 5, that's 30x. And then again, we'll use our diagonals. All right, so we know the x's are going to be contained in this diagonal. I've got 30 x's. I need 28. So I've got a little too many, two too many to be exact. So we're going to need a -2 x in this box. Right, and then we think, well, x times something gives me -2x. That's got to be a -2. So -2 times 5 is -10. and that matches up, right? So that divided into it perfectly. That means x plus 5 is indeed a factor, and we have the result of that division right here. So we know that x plus 5 times 20x squared plus 6x minus 2, these two things being multiplied give us our original polynomial, all right? So my other two factors are contained inside of this quadratic. We just got to go get them, all right? And that's where the quadratic formula comes in very handy, because we can use the quadratic formula to break this thing apart, all right? So that's exactly what we're going to do. We're going to take the quadratic formula. We're going to find our A, our B, and our C. Remember, we're working with the quadratic, so we're working with this only right now, and we're trying to find the two roots that exist in here. Okay, so here we go. A is the number in front of x squared, that's going to be 20. B is the number in front of x, so that is 6. And C is the constant on the end, that's -2. And then we set up our quadratic. So we're going to have -6 plus or minus the square root. We're going to have negative b squared here. So we've got b, actually, it should just be b squared. I don't know why I did that. Anyways, b squared would be 6 squared minus 4 times 20 times -2. Go, all over 2a. So that would be 2 times 20. Right, and then just one thing at a time, simplify one thing at a time. The -6, nothing that we can do with that. The 6 squared is 36, so that's easy to do. And then 4 times 20 times -2. So remember, this is a -4 and a -2, so there's actually two negatives in this multiplication, so this entire thing is going to turn out to be positive. Let me pull up my calculator here, and we'll crunch that number. So we got 4 times 20 times 2, and we get 160. Right, and that'll be a plus 160. And again, that's because we have two negatives, right? So negative times a negative makes a positive. So there we go. And then 2 times 20, that's 40. All right, let's keep going. So -6 plus or minus, we got 36 plus 160. So that's going to be 196 over 40. Getting easier here, almost to the end. -6 plus or minus, the square root of 196, I believe, is 14, but let me double check that in my calculator. So we got the second square root, 196. Yes, it is 14. There we go, all over 40. All right, we're almost there. I'm going to go ahead and split off into two answers here. All right, so we got -6 plus 14, so that's going to be 8. And that'll be 8 divided by 40, right? And then we got -6 minus 14, so that's going to be -20 divided by 40. And then this one, I do 8 divided by 40, 8 divided by 40, and there's a 0.2, so we'll convert that back to a fraction. There we get 1/5. And then this one will be -1/2. And there's our two roots, right? So we find our other two roots to be x equals 1 over 5 and -1/2 over 2. So there's our other two roots. And I'm going to take those, if those are roots, and they are, we are going to write the factors, right? So if I have a root of positive 1/5, I need a factor of x minus 1/5. And then if I have a root of -1/2, then I need a factor of x plus 1/2. And then all of our roots, right? We've got -5, 1/5, and -1/2 as our three roots. Okay. All right, let's do it one more time. We're going to run through that process one more time just so you can see it. We've got a third degree polynomial again. So again, step 1, check the graph, find an integer root or a nice root if it exists. Okay, so we're going to get rid of this one, graph this one, and let's go through these. So that's not a nice root, that's a decimal root. This one, 3. Okay, so 3 is a nice root or an integer root. So we found a root of 3, which means we'll have a factor of x minus 3. All right, and I'm going to set up a Polydoku here. So we're taking 25 x cubed minus 75x squared minus 16x plus 48 all over x minus 3, right? This is the division problem that we are doing. We're essentially dividing out this factor so that what's left is the thing that contains these two roots, all right? So here we go. We're going to put the x minus 3 here along the side, write our 25x cubed minus 75x squared minus 16x plus 48 here across the bottom. Okay? So 25x cubed will go in that first box, and we're going to need something times x to give us 25x cubed. Well, that's got to be 25x squared. Then we multiply it down, that's going to be negative 75x squared. Diagonals, right? So this one is weird, right? Because we need negative 75x squared. We have negative 75x squared. So that means this one has to be a 0, right? So when I add these together, we got to get negative 75x squared, but I don't need anything else. So I'm just going to put a 0 in that box. And what that tells me is we're going to end up with a 0 here, right? Because 0 times x is 0. So 0 times negative 3 is also 0. And then again, we pay attention to our diagonals, right? So this is where the x's are contained. We need negative 16 of them. I currently have 0. So we're going to need negative 16x up here. All right. So now x times negative 16 will give me negative 16x. And then negative 16 times negative 3 is a positive 48. And we check to make sure that those match at the end. If it does, that means x minus 3, we just confirmed that it is a factor because it divided into it evenly. And we also have our resulting polynomial, right? This result piece here at the top is the result of this division, and this is where our other two zeros or our other two roots are contained, okay? So what we have just found out is that x minus 3 times 25x squared minus 16, right? These two things multiplied will give us back our third degree polynomial. Now when I write this out, because I know I'm going to be using quadratic formula, I write this out as plus 0x minus 16. That way I can keep track of my a, b, and c. All right. So here we go. We've got a, b, c. A is 25, right? That's the number in front of x squared. B is 0. That's the number in front of x, and negative 16 is the constant on the end. So here we go, we've got negative b, so that's just going to be 0 plus or minus the square root of 0 squared minus 4 times 25 times negative 16 all over 2a. So that'll be 2 times 25. All right, so 0 plus or minus. We really don't need the 0, so we can just say plus or minus the square root. Now 0 squared is just 0. Now when I multiply these three out, right, there's a negative 4 and a negative 16. So that's that double negative situation. So we are going to have a positive number inside that square root. So we got to do 4 times 25 times 16. And we get 1,600. Seems like a big number, but it's not a problem. Right, and then in the bottom we've got 50. So I'm going to go to my calculator and do the square root of 1,600 real quick. We got 40. So we've got 40 over 50, and that'll be plus or minus 40 over 50. So we're going to have 40 over 50 and negative 40 over 50, and these will both reduce to 4/5 and negative 4/5. And there's my last two roots. So I can say I have another two roots, and they are 4/5 and negative 4/5, right? Now, if I have a root of positive 4/5, that means I have to have a factor of x minus 4/5. And if I have a root of negative 4/5, then we have to have a factor of x plus 4/5. So there's my factored form and our listing of roots right here. So there's our three roots for our third degree polynomial. All right, guys, that's it for today. Make sure you give the practice problems a try, and if you have any questions, make sure you let me know in the Zoom chat. Have a great day.